Okay. Hello. Hello, Hafad. Hello, Izan. Hello, Abdullah. Hello, Hamza. Hello, Bahadur. Hello, Abu. 1, 2, 3, 4, 5, 6. Good morning. Alif. Yes. Okay, so I hope you are doing good. So what we can do is we can have a review of Newton's law, I suppose, right? I was about to start a new topic, impulse momentum, but I don't think we have too much time left for it, right? Tomorrow you have an exam. So let's do these problems. Now just remember one thing. I have already told you the topics that are included for tomorrow's exam. But as Hamza was asking yesterday, you need to understand, I also responded to him, the concepts are pretty much interlinked. You got it? So once you are doing this problem, you will see that it will involve concepts from what you have studied in midterm 1, for example. Okay, let's do this problem. So that, of course, that's not my fault, right? Things are interconnected. The question says, hello, Marij, how are you? Hello, Hazel. So the question says that you have a slotted arm, revolves in the horizontal plane. Just read it yourself. So in this question, we will go over, the question says, we have to do what? Determine the tension T in the cord. The question says that I have nice and beautiful weight given to me in the solution as 3 pound. Please bear with me. It's not my fault that this is an English system. I couldn't come up with a nice SI. Okay, what is R dot? Let's see if we have any student who can tell. Should I reduce the light? Huh? It's okay. Okay, what is R dot? Anyone? Minus 2 inch per second. Okay, what is R? Anyone? 9 inches. What about omega? Nice answer from one of the students. How many agree and how many disagree? What about theta double dot? -2. How did you figure with the minus? Okay. And how did you figure the theta dot as positive? Yeah. Okay. Anyways, I will not contest that. In this, there is another rule. But if someone wants to follow counterclockwise as positive, even then your answers will come out to be correct. Okay. What about the slot? Does it have friction? No. Smooth slot. Okay. What are my unknowns? Tension T. Question mark. Okay. What else? Normal force? Question mark. Okay. What about the free body diagram? Here comes my nice and beautiful mass. Okay, make a free body diagram. Quick, 30 seconds. Look, when this whole thing is taking it like this, of course, the mass has this push to it, right? So there is a normal force. Okay, good. What about the coordinate system? You know what? It feels to me, r theta. Good. So it feels to me there is an r theta. So I will go like, Marij, can you hear us, by the way? Marij? Okay, I think Marij responded. So this is r outward theta. I will take it like this. Students who don't like this, you can put it like E caret r and E caret theta if you don't like r and theta, whatever, as long as you understand that one is radial, one is. Okay, and what about the angle? We have 2 messages. Oh, come on. By the way, you are all welcome to just unmute the mic and just contribute. This is theta angle. This is E caret theta or theta. This is E caret r or r. Okay. Don't read it as RER. Oh, come on. This is R or ER. This is theta direction or E caret theta. Okay. What else? What about the tension? Come on. What is the tension? That was a nice answer. I suppose there is a 90-degree angle between the two fellows. Huh? Like this. So anything else? What about the normal force? Oh, come on. Did I make the normal force? Yeah, what is this arrow? This is the normal force. Okay, whatever. I think I should have made it like this when it is in contact with the. So probably I will correct myself, although won't change too many things. Just doesn't feel that nice. So I will. Oh, come on, come on. Okay, this is your nice and beautiful. I think you get my point. How to move this thing now? Oh, okay. This is my E caret theta direction. This is my E caret R. Okay, solve it. So I will have now nice and beautiful. Huh? We should have.
Also friction force.
No, there is no friction. Wow, he's right, by the way. Where on earth is mg, by the way? I don't know why.
This acting downwards straight.
This is a horizontal plane. The first one.
Very good remark. Excellent remark from our students. Both the students are coming up with good perspectives. Okay, so read the question. It says, thank you. It goes in a horizontal plane.
So John, we are looking from up here.
We are looking from the top. So the weight is downward. If it had friction, what would have happened? Then friction between the slot and that one. Anyways, my point is that the weight is acting downward right now, and that's why in the R and theta, the weight doesn't come into the picture. Did I elaborate myself? Should I continue?
What was the point?
His point was, what about the weight in the free body diagram? And his response was that it's in a horizontal plane. So you are talking about R and theta. Yes. R and theta will not have any weight. Thank you. Okay, everyone, solve it for me, please. What happened? Okay. We will have normal. We have tension. Let's finish the problem. What are the equations? Anyone? No, tell me the equation. Summation of forces in the radial direction is equal to MAR. Now, technically, AR and A theta kind of a kinematics technically is not included, right? When I wrote that email. But that's not my fault that the concepts are interconnected. This is included. If this is included, then for sure you need to know AR and A theta from your midterm 1 as well. Okay. Are you getting my point or not? What is AR? Yes or no? Okay. What are summation FR? Okay, do it. Do it quickly. 30 seconds. Summation of force in the radial direction. This is the tension, right? So put the tension in the radial direction. Okay. Minus T. Yes.
Instead of using these equations for AR and A theta, do we use the longer acceleration formula?
The problem is, okay, I will answer this question after I am done with this. Once, let me write the answer and I will answer your question. I can answer your question right now. Look, what you have to understand is that big equation for the you can do it. हाँ, मतलब you can do it. मतलब you will have to, you should, I would advise to rotate the coordinate x's as y and x in this direction, solve it, then do summation of f equal to m in the x direction and m in the y direction. Yeah, you can do it. But this is more convenient if you ask me personally. Minus t equal to,
3 over 30.
good. Very nice answer, 32.2. Students who are getting confused, I will put like this. Multiply by r double dot. Sure? Did I tell you?
R dot is a constant, R double dot.
Okay, r double dot is a constant. I will agree with you. Minus, then I have r theta dot square. R is the position given to me as 9 inches divided by 12, multiply by theta dot given to me in radians per second. So T comes out to be 2.516 pound force. Okay, lbf. Okay, similarly, I will give you summation of force in the theta direction. It will give me, please bear with me. The normal force is in what direction? Positive theta direction. So I will have positive n equal to m a theta. Why positive m a theta? Because 99% of the times when I write summation of forces is equal to ma, hang on everyone, 99% times probably, or 95% of the times when I write summation of forces equal to ma, I prefer to play with the summation f. I play with the left side. ma I usually don't play with. So that's why I'm taking it in the positive direction 95% of the time. So that's why I will have m into r theta double dot plus 2r dot theta dot positive n. Give me the answer quick. 3 by 32.2 into
9 by 12.
please give me value. I don't have. Multiply by what is theta double dot?
Given.
Minus 2. Okay, I will involve all the students who have just come. I will just finish the answer and then 2 r dot theta dot, right? Okay, any student who is planning to tell us why is r dot given to me in the negative value? Why r dot is negative? And in the meanwhile, you can take a picture. Students who have just arrived.
Opposite to the R axis.
Good.
Decreasing.
What?
Moving towards the center.
Good. That's the exact answer. So students who have just arrived, the question said that you have this mass attached with this little string. Can you see the string? This one, string. You see string? So this whole thing is rotating in the horizontal plane. The question says horizontal plane. In an exam setting, if I give you horizontal plane, let's say you have to focus horizontal plane. If it's in the horizontal plane, because if the question is like this, then weight comes into the picture, right? But if it's like this, the weight doesn't come into the picture when you talk about r and theta directions. So the question says, why don't you tell us how much force that slot arm puts on the mass? Because when it's going like this, the mass has force on it, right? So I have to find the normal force. I have to find the tension in that string or cord. Because the mass wants to go away, let's say, and the string wants to hold it. So I did a summation of forces in the radial direction is equal to MAR, and I did a summation of forces in the theta direction equal to MA theta. I defined my radial outward as E caret R, and I defined my theta direction as E caret theta. You either write this or you write this for direction. I don't know. I prefer this. I prefer this one. You write this or you write R for your direction coordinate. I prefer the E caret R. Then I said normal force is in this direction, tension is in this direction, and I just solved the problem.
And also the omega becomes positive because it's in direction of increasing theta, right?
Very nice. That is the correct statement. Good. He said counterclockwise, I take his answer as well. But your answer is actually pretty accurate. Okay, so any questions for me today? Okay, last but not least is what is the direction of the normal force? So you can see that N has come out to be negative. The question said,
Assume to the opposite.
uh, indicate which side A or B of the slot contacts the slider. B? Because if N is in this direction, then that slide is in touch with it. Makes sense because if this whole thing is going counterclockwise, the left side is in contact, I suppose.
Hocam, I think the A is connected with C.
No, N is coming out to be in the downward direction. So the answer is at slide B.
Or it can-
So I will say at side B. Okay, I will stop here for a few seconds for our students to have a look. So apparently you need to have a grip on the concepts taught before mid one as well, right? These concepts were included AR and A theta for your mid one, but they are being used here. So of course you need to have a grip over them, okay? The concepts are interconnected. You can expect such kind of a question in your exam, let's say. Should I continue? Positive, huh? Okay. Okay, why don't you do another problem for me quickly? So let me do a problem for you. Nice and beautiful problem. Probably few students might have already done this, huh? In your exam preparation. I'm covering few of them because I want to make sure that everyone is following. Okay. I just cannot. Otherwise, I had prepared another topic for you today. But like you, I am also worried about midterm too. Okay, come on. Come on. Okay, do it. Use your imagination. Let me zoom it in for our students who are sitting right at the back. Oh, come on, now the picture is gone. Yeah. Anyways, first write this and then. Along the horizontal rod, right? In fact, this question is pretty clear. Goes like that, right?
For example, in this question, we can use the long acceleration. Yeah,
But you are no, you're not following my point is that for sure you can use them. But then just remember that when you are doing the summation of forces in this and that direction, as long as you can, for example, one of the students attempted the last crane problem, quite a few students actually, 4 or 5, with AR A theta. Technically, they can arrive at the right answer, but usually they couldn't because it becomes a little hard to make projections and everything. In principle, you can, and probably you could if you want to. But if I were you, I will just go for AR and A theta. That's straightforward in this. Summation of force in the radial direction is in this. Summation F theta is in that. Boom, game over.
Now, will you give the formula for AR? and
I can, that's not a problem.
Nice.
If I forget, I will just provide you. Okay, make a free body diagram, ladies and gentlemen. Okay, so I have to zoom out, by the way. Sorry. So now we will start together. What do I have in this problem? Can everyone see, still see the problem, or should I copy paste again? I don't know. I have to proceed. So we will do mass is equal to, this is 50%, I suppose. It's not visible, not even to me now. So mass is equal to 0.8 kilogram. Then I have theta dot is equal to 6 radians per second. Then I have R dot is equal to positive or negative? Okay, very nice. Positive 800 millimeter per second. Good, good. Mu k is 0.4. And I have to come up with a nice and beautiful solution.
Also, we have acceleration.
Really?
We say radian per second is constant.
Huh?
We say 6 radian per second is constant.
Constant.
So,
Which is rotating.
double dot is 0.
Okay, okay. Okay, good, good. Very good. Theta double dot is 0. Okay, then calculate the friction force F exerted by the rod on the collar. So let's call this nice and beautiful fellow as F or FF, whatever. Let's make the free body diagram. So the free body diagram will be, this is the collar. Let me look at this picture. And then I will create my axis. My R will be boom. My theta will be 90 degree to it. 90 degree is this one, correct? Are you getting my point? Looks to me as 90. I am more comfortable with E caret theta. Oh, sorry. E caret R. And I don't know where is theta. So it's entirely up to you. Now there might be students who are saying, consider this as clockwise as negative, and why don't you make theta in this direction? Actually, in this particular problem, they haven't given us the theta equal to 0 line. Are you getting my point? So it's entirely up to how you approach the problem. You can actually consider this as positive. If you don't like it, I don't blame you. You can consider this as positive theta, as long as it's 90 degree. Okay. Now, what you have to understand is that now theta dot has become positive, right? Now theta dot is positive. If you want to take theta dot as clockwise as negative, I don't have any issues. Then probably the theta direction that you have to consider will be different. Okay. Now that you have made it 90 degree, you have to do a summation of forces. So my first will be, let me make light blue color for all of you. My F theta will be, oh, come on. In this direction? This is F theta. What about the weight? Downward. Mg. Let me use a pink color. What about the normal force? It will be upward. Ny. What?
There is inclination for normal force.
Okay, this is Y. And this is, I don't know where my X is. Yeah, what happened?
The FT, what is FT?
F theta is perpendicular to R, na? So this is R. This is F theta. Theta is 90 degree. This is 90 degree.
Is it reaction force as well?
Which one?
The F theta.
Friction, F theta?
F theta.
No, F theta is the force in the theta direction. Is it?
Is the reaction force?
I suppose it will be the, should be the,
Reaction, right?
F theta is ma theta, Mehmet. F theta is ma theta, force in the theta direction. Okay. Okay.
The reason of this F theta is the movement of the color, right?
Huh?
Because if it turns like this, there must be a reaction force.
No, I will answer your question after 10 seconds. I understand the question. I will answer right now. F.
And it has some interrelation.
That's why I put NY. I will answer both of your questions like this. F theta is equal to ma theta, which is equal to R theta double dot plus, what happened? R dot theta dot. And okay, and then I have equal to M. What is R theta double dot? 0 plus 2 multiplied by R dot is 800 by 1000 multiplied by theta dot is 6, right? Radians per second, I suppose. So F theta comes out to be 7.68 Newton. Look, if you're not, my only point is I have called this as F theta. Okay. Now you have got your F theta. What is our yeah,
Fy is 0. Y equals to 0.
summation Fy equal to 0. So let me use a y. Summation of Fy equal to 0, and I have positive Ny minus Mg equal to 0, and I have Ny comes out to be 7.848, right? Okay. And then normal force. Okay, now I understand Mehmet's question. So if you are not comfortable with F theta, I understand your question. You can put it as another normal.
Normal.
I understand the question. Yeah, thanks for pointing out at that time. I will correct myself. So NA will be, good remark, thank you. 7.848 square plus 7. I think this was his question. So thanks for indicating. I will correct myself. Change this F theta to, oh come on, this is Ny. Change it to N theta. Okay. Thank you, Mehmet. N theta. Like F theta, N theta doesn't matter, but I think I understand his concern that why are you using F theta? So I will say N theta. Now there are students who are saying, what on earth is happening? Why did you use N theta? Well, the question is pretty straightforward, right? You talk about normal force because this plane has to offer, right? But what if the whole thing is going like this? Apart from the fact that the whole collar is touching this surface, it is also touching this surface, right? So there are two normals. So that's why I think his point was, why don't you use N theta? So now I have N theta because the Ma theta is countered by the fact that the rod is touching it. That is the N theta. And the fact that the whole collar is resting on the rod, there is a weight and normal force, as you understand. So I have Ny and I have N theta. I need to stop for 2 minutes. Is this clear? Are you confused or not?
Why the side polar coordinates?
For this one?
Yeah, for example, in this question.
it seems pretty natural, no, that the thing is going back and forth. By the way, where did the friction come into the picture? Didn't he talk about friction?
No, we didn't talk about friction.
I mean, there's no force in the part beyond that.
Huh?
It's just itself, right?
Oh, we have to calculate the friction force. I think I don't have the complete solution. So I think there is calculate the friction force. Sorry, the question hasn't ended yet. That's not good. So calculate the friction force. So F equal to mu k times N, which is equal to 0.4 into 10.98. How did you figure? Did you square root them?
Yes.
Huh? Good, good. Very good. 10.98. What happened to paint? 10 point, which is equal to, I don't know, 4.39, I suppose. Okay. I think life is beautiful again. Sorry. One minute. I will take your question. You can also add a arrow here, by the way, if you don't like. If you like, I think free body diagram needs to have a friction force as well, I suppose. Okay. But then there is a spring as well. But we don't know the spring force, I suppose. So you could have added another arrow in the same direction. Yes, Mehmet.
While deciding the polar coordinates,
Huh?
we know that the ER must be in
Radial
increasing R direction.
Uh-huh.
And also E theta must be increasing
Theta direction.
theta direction.
But here the theta equal to 0 line is not given. So he could have taken clockwise as negative and made an appropriate E theta in this direction. You could have followed this one because theta equal to 0 is not given to me.
So in our calculations, we said that theta dot equals 6 radian per second.
So
I think it must equal minus 6 radian per second because it's in negative
really?
direction. I don't know, yeah, is that because we decide E theta towards left, yeah, for my left.
Probably, I don't think so, but what should I say about this? Anyways, probably you are right. I don't know. Seems correct with the answers and everything. You can think about it.
So therefore, our answer will be changing.
No, everything is fine.
Yeah, absolutely.
I don't know. Seems correct. R and theta should be 90 degrees to each other. Okay, now let's do another problem quickly. Instead of doing this problem, should I open the textbook and make you work on an example, if that's fine with you? Huh? Okay, let me make my life easy as well, little bit, please. I think I also need a coffee today. I will.
Can you stop the last question of this video?
Acha, okay. Right now? No, not last. We will do second last. The last has an angle, right?
Yes,
Let's do a second last. Acha. Right now? Okay, we have a student who has asked us to solve a problem. Look, this one you will do yourself. I can do this one for you. Okay. Okay, we have a. Okay, do it, everyone. Start. Start part. Yeah, I will. I do realize that this is barely visible for you. एक minute. Should I do it more? Mehmet? No. Ahmed. Ahmed, should I do it more? Sure. Okay. Oh, that's not good. Good remark by you, by the way. You did the right thing. This is a good problem to solve in a class. So if I were you, I would have revised my rigid body kinematics. I would have revised, of course, the rest of the topics. I'm just going over quickly. The work energy, the Newton's law, the pulley, everything. Constrained and unconstrained motion and everything. One minute. I will take it for yes. The normal force should be the normal force shouldn't be a 90 degree. No? Okay, we will do it together. Should I start problem by the way? Okay, let's do it together. Come on.
So R, I think.
No, it doesn't say.
Like this. This one? No, this like this. So what is the slope?
It doesn't say in the horizontal plane. It does not say in the horizontal plane. So it's a system like this, like in this plane. Okay. Let me start the solution for you. Anyone who made the free body diagram want to show us or discuss? Let me go at sonic speeds now. Oh, come on, where is it? So bear with me, please. I will copy paste this thing, sonic speeds. Okay. Okay, let's do it together. Number one, free body diagram. For the free body diagram, I have, let's say, this is my nice and beautiful R. Then 90 degree, I have nice and beautiful theta. I call this fellow. Look, here there is no problem. Theta equal to 0 is given to you. Huh? If theta equal to 0 is given to me, then I will have E caret theta, E caret R. This is my E caret theta. This is my E caret R. Okay. Now I will have, let's suppose this is my increasing theta. And the question says, this is my, please bear with me. Okay, this is my length L given to me. Okay, there is one force in this direction. Oh, okay, now I understand the question of Hamza, because it's not easy. There is one force at 90 degree. I now understand your question. So there will be a force in this direction. Come on. This has become a little hard for me. I think I can't take over. Okay. This is F. Then I have a capital N or whatever symbol you want to use for this one, because this is the wall as well. Then I have the weight acting, boom. And then I can use some other fancy colors for the velocity and acceleration. And this is my, where is the acceleration? I don't know. Anyways, this is my V. So this will be my VR. This is V theta. Now you have to be careful that in an exam setting, if you are planning to talk about velocity and acceleration on the same diagram, you need to use different color, okay? You don't on a free body diagram start using the same color and start putting everything like this. Are you getting my point or not? This is known as a, what was the name? Kinetics diagram. Have you heard of it in your physics? One is called a free body diagram, one is a kinetics diagram. These velocity and accelerations, usually people make on a kinetics diagram separately, but I am putting everything on the same thing with different colors. You call this as your V theta, let's say, and this is your VR. Okay, now let's solve it. Number one, we will say summation of forces in the, oh, where is the solution? Come on. Please bear with me. Okay. Summation of forces is equal to MAR. Agreed? Okay. Then I have summation of forces in the radial direction as N cosine 30. Then you have minus mg. Why don't you tell me this? This is the theta.
mg sin theta.
Everyone understands how he figured out? Okay. Is equal to m multiply by AR.
Hocam, can we write instead of AR, A sin theta?
So what is A? Did they give us A?
No.
Where is A?
We found,
I don't have the question.
we will find the calculations.
How will you find A? Okay, we will find A. Anyways, let me proceed with summation of forces in the theta direction then. Okay, so now that I have all of this, let's find out the AR and rest of the quantities. So I will say cos theta dot is 45 degrees per second. Then I have theta dot is 0.785 radians per second. Then I have theta double dot is 20, which I will use in 0.349 radians per second square. I converted. Then I will say cos theta is equal to base over hypotenuse. What is the hypotenuse? R. Yeah, okay. Then cos 30 is equal to base is, did they give us L value by the way?
Yeah.
Sure, okay. 0.6 divided by, oh come on, R. Then I can find R. R comes out to be 0.577, no? Double check please.
0.693.
Really?
Yes, hocam.
Solution is wrong. Oh, I think I'm looking at the different solution. The L that we have, are you sure it's 0.5 or 0.6?
0.693 hocam.
1 minute. Please bear with me. L is 0.6. Okay, I have opened the wrong solution. That's not good. That's fine. Okay, so you have to tell me the value. 0.69 you said.
693.
0.698. Thank you. Okay. Okay, life has become a little complicated, but I think all of you can use the calculator and you will keep on helping me. So now that you have got R value, then what will be the velocity of the slider? We will finish the question by saying V in the theta direction, VR is equal to R dot. What is V theta? R theta dot. So we have R theta dot as, okay, so if I have, let's say this velocity, and I want to calculate V theta, what will be it? It will be V multiplied by cosine theta. Okay, and from here, I can get the value of,
V is
huh?
Why are you finding V?
Why are we finding V? Well, we have to find the V because we want to find R dot. Radius per second. I did convert it. I did. Theta dot is 0.785 up there on the top. Let me answer Hafaz's question. Hafaz asked, who asked the question? I forgot. I think he asked the question. Now he's talking about it. Okay, his question was, why are you finding V? Oh, Hafaz, you asked me the question, why are we finding V? My response is that when you are doing the summation of forces in the radial and theta direction, you have those big expressions. Those big expressions have R dot, theta dot. That's the R dot that is bothering us. We don't know R dot. What is R dot? R dot is nothing more than VR is equal to R dot and V theta is equal to R theta dot. So the path we are following is, if I crack somehow the velocity, I will be able to calculate the radial component of velocity. Once I get the radial component of velocity, that is R dot, then I will proceed to talking about the summation of forces in the radial direction. Did I answer your question? Huh? Everyone, you have to be sure of the formulas. Just a formula sheet in an exam setting will not gonna help you if you don't have an idea. Now that I have the velocity, what is the velocity? Okay, the answers are wrong in my notes.
0.627.
Okay, now that you have got the V, then you will find, good. VR, and I will be using nice and beautiful pink color. VR equal to 0.627 V. So that will be sine theta, I think. Sine of 30. So VR comes out to be equal to R dot equal to
0.3135.
So you have to understand, it depends on how you think a problem. I have the summation of forces in the radial theta directions. Oh, wow, these are my unknowns. Then you go back and you start finding all those things. Okay. Now that you have everything, we are feeling so happy. The problem is how to find this fellow. This is my problem. So AR has R double dot minus R theta dot square. Do I have R double dot?
Yeah, it's 0.
Are you sure?
Yeah. Because R dot is constant.
Where did it say?
Because
We found R dot, it's constant.
No, 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 no.
It's
Look, hang on. Let me answer your question. Look. R dot value is a constant that I'm getting. Is it changing or not? In this particular instant, I have this R dot. It's quite a possibility that in the next millisecond or nanosecond, it will change. So just because you have got a constant value, doesn't mean it's a constant. You have got a value. That value is value. So we don't know. So we will go back. By the way, we started off a tricky problem, by the way. Anyways, I'm happy that we are doing it. I hope we end up completing it. Hello, internet. Okay, you have to bear with me, please. So now I will say A theta is equal to R theta double dot plus 2 R dot theta dot, and R A theta is A cosine theta, which is equal to R theta double dot is, what was the value of R? It was 0.693 as one of the students told me. Theta double dot is unknown to you. It is given, sorry.
0.340.
341?
9
349?
Yes.
Okay, thank you.
plus
Plus
so
R dot is
0.3145.
3135. Please bear with me. Theta dot is
0.785.
okay. Then I get A is equal to 0.
0.7336.
Now